Good morning, everyone. Myself, Manjunath B, Assistant Professor, Department of Civil Engineering, SJEC. I welcome each one of you for today's webinar on soil structure interaction and deep foundation and theory and applications, hosted by Department of Civil Engineering, SJC, in association with ISTE SJC Students Chapter and WICE 2020. And this is our third webinar under WICE 2020. I wholeheartedly welcome our resource person of the day, Dr. G.R. Doddagoudar, Professor, Department of Civil Engineering, IIT Madras. I welcome you, sir. I extend my warm welcome to our management principal for this webinar. I also welcome our HOD, Dr. Igneshwaran B., convener, Mr. webinar. I now request our beloved HOD, Dr. Igneshwaran B., to speak a few words about this webinar.
Can you hear me, sir? Good morning to all. On behalf of FJ's family, I like to express my sincere gratitude to the respected Professor Dr. G.R. Doddagoudar, IIT Madras, for accepting our invitation to share his expertise in soil structure interaction and deep foundation in our ongoing webinar series WICE 2020. I wish all the best to this program. Once again, I welcome all the participants to this webinar. Thank you.
Thank you, sir. Before starting with the session, let me first introduce our resource person of the day, Dr. G.R. Doddagoudar. Dr. G.R. Doddagoudar, Professor, Head of Geotechnical Laboratory, Department of Civil Engineering, IIT Madras. His areas of interest are geotechnical, earthquake engineering, seismic soil structure interaction, analysis of rain-induced slope instability, seismic microzonation of urban centers, contaminant transport, stochastic soil dynamics, analysis and design of piled raft foundation system, performance-based earthquake geotechnics, seismic reliability analysis, computational geomechanics, nonlinear finite element analysis, landslide hazard and risk analysis, and fuzzy logic in geotechnics. It's our privilege, sir, to have you for our webinar. Now I request G.R. Doddagoudar to start.
Okay, thank you, please. Please share the content, no? Hello?
Yes, sir. Yes, sir.
Hi.
Your presentation is visible.
Yes, it's visible, no?
Yes, sir. Yes, sir.
What about my audio quality, please? It is okay?
It is fine, sir.
Okay. Thank you for that introduction. My name is G.R. Doddagoudar. I am from IIT Madras. The title of my presentation is Soil Structure Interaction and Deep Foundations, Theory and Applications. Before moving on to the actual outline of presentation, I want to show a few slides as part of big picture related to the presentation. If at all you want to have books, most of the books are available online through this first website, that is genlibrus.ec. In case you want to know the papers maybe published in journals or even conference proceedings, you can use the second website, that is scihub.tw. Maybe 90% of the journal papers are available through this. Okay, this is the big picture about foundation analysis and design. Initially, we'll start with the structural information and expected loading at the foundation level. And then you will going to have the subsurface exploration report. From that, you are going to analyze the ground properties as well as depth through bedrock, and also you will going to evaluate the depth of foundations. And then you have to decide, depending on the structural loading and functionality of your structure, you have to decide whether you have to go for shallow foundation or deep foundation. Once you have gone for shallow foundation, you have to set for these criteria. These are the criteria one has to satisfy. First one is the bearing capacity, that also corresponds to ultimate limit state. Another one is a settlement analysis. Based on these two considerations, again you have to pose a question is a shallow foundation is acceptable? If it is acceptable, please go ahead and then prepare the contract document and then go for construction and quality assurance. Again, you have to go back here. If the shallow foundation is not suitable, if the ground or the below the foundation, if you don't have a good ground, then you have to go for deep foundations. Especially in case of deep foundations, one has to be very, very careful with respect to static analysis, wherein you are going to address these two requirements. First one is the bearing capacity, another one is settlement analysis. Especially for dynamic analysis, in case of deep foundation, one has to be very, very careful. Usually deep foundations are pile foundations, well foundations, drill shafts, or even filed out foundations. Once you accept it, it is as usual. Prepare the contract document, go ahead and construct, and you have to ensure the quality assurance. It is very, very important. Out of all foundation engineering activities, construction is one of the most important activities. One has to be very, very careful during construction. You have to meet all the requirements before going ahead and continuation of the foundation construction. Okay, how are you going to develop the design methods in foundation engineering? These are the simple ingredients associated with the design methods in foundation engineering. First, we'll start with the field and laboratory observations. Then we're going to develop the theories. And then when theory is not going to work, then we're going to refine those theories. That's what research. Then once you have accumulated experience, then you're going to revise or you are going to refine the design methods. Basically, analysis and design methods will go hand in hand in foundation engineering. Okay, this is just a building model. Actually, it is constructed in Bangalore. The name is Jain Swadesh apartment. If you consider it the fixed base structure, that means you are disregarding the presence of soil or any geologic material. Indirectly, what are you saying here is stiffness of your geologic material is much higher than your structure. Then only you are going for a fixed base structure. Okay, if at all you want to consider the presence of soil, let's assume it is a raft foundation below that structure. You can replace your soil with a bed of spring. That's called Winkler hypothesis that they have used, and then also they analyze the building. Later, this is what is the model on Winkler model, and then the raft is also discretized, and then the Winkler springs have been evaluated. Basically, what they have done here, they have considered the independent Winkler springs. In case you want to bring in the continuity, one can go for the coupled springs. Even if you don't want to use this Winkler hypothesis in order to analyze your soil foundation structure interaction, one can think of using a certain amount of soil beneath your foundation. Here you are considering a soil as a continuum element. You are going to divide the soil into number of continuum finite element analysis, and then you're going to have the proper boundaries, and then you're going to use the finite element software. You're going to analyze the structural response. Then you will go ahead and construct the structure in the field. Okay, with respect to the deep foundations, take for example, it is an isometric view of pile supported structure. It may be any structure. It may be a pile supported bridge abutment. It may be pile supported bridge piers, or for that matter, any building. How are you going to analyze? Okay, these are the piles. This is what is your cap. If the cap is going to transfer certain amount of structural loading, in that case, it is called as a pile raft foundation or combined pile raft foundation. How are you going to analyze? As far as our present title is concerned, I want to tell you two approaches. One is a substructure approach. Another one is a direct approach. In the substructure approach, how are you going to model? First of all, you have to reduce your physical system into equivalent mathematical model. Once you say it is mathematical model means simply differential equation. Once you have this particular model, you have to think of using substructure method. Earlier, we used to use substructure method, but nowadays there is no point in going for this. Nowadays, softwares are so powerful. In single go, you can analyze combined soil structure system. Okay, how are you going to analyze your soil structure interaction effects considering the substructure approach? These are the ingredients of substructure approach. This theta FIM and then UFIM are the foundation input motion with respect to rotation and translation. Then basically, what are you doing here? These are the pile elements. Then the soil is replaced using these set of springs. In order to take care tip resistance, you're going to use this KT. And then in order to take care of your PY resistance, you're going to use KH. In order to take care of the skin friction, you are going to use a KV. Then you combine with the structure, then you're going to perform the soil structure interaction analysis. In this case, only linear analysis is possible. Basically, you are splitting into two parts. Then you are analyzing and combining the response. Combination of response is possible when you consider only linear analysis. Okay. Next, what you will do, if you don't want that analysis, one can go for the complete or direct approach, wherein in the same file, supported structure is shown over here. The soil elements in and around your foundation can be treated with some other finite element. Basically, these numbers stands with respect to abacus foundation. If at all you want to bring in the infinite soil conditions, you have to go for infinite soil elements. This is what is our pile cap with pile numbers. And this is what is our integrated soil file model. With this, then you have to apply the boundary condition, you have to specify the material loading, and then you have to apply the earthquake loading somewhere here where you have the bedrock. This is very, very important. In case of fixed base structure, right below your foundation, you are applying the earthquake ground motion, then you're going to perform the seismic response of structure. Otherwise, if you have a soil, the structure is supported on soil, internal is supported on the bedrock. At the bedrock level, one has to apply the ground motion, basically acceleration versus time, and then you have to perform the analysis. Then you have to look for all the allowable even bending moments, shear forces, or displacements. Okay, this is what the big picture about the present title. This is what is our outline. First, I want to start with a few quotes, followed by introduction, and then few definitions, and then the big picture about the geotechnical engineering, earthquake engineering, then followed by a little bit about sustainable development. Anyway, we have to go for development. When you are going for development and progress, you please keep this in mind. Sustainability is very, very important. Otherwise, there is no point in going for. Otherwise, what will happen? You will not going to keep anything for the future generation. And then how the sustainable development will be useful in case of engineering and design. And then a few books, especially for the students, those who want to explore this particular field. There are standard books. Most of the books are available online through those web pages. Then I want to tell you how are you going to learn concisely. There is no point in using brute force approach. Nowadays, you can use the techniques. And then I want to explain a little bit about mathematical modeling of a physical system. Then followed by basics and analysis of soil structure interaction, the kinematic interaction, then inertial interaction, and then analysis of simple soil structure system. Then I'll go on to the soil file structure interaction. Herein I am going to discuss a little bit about forms of loading, pile subject to axial loading, pile subject to lateral loading. How are you going to use the differential equation in order to know the pile resistance to the applied loading, and then coming to the pile groups, and then finally dynamic response analysis. And then I'll discuss only one of the methods, that to the beams on dynamic unipolar foundation, followed by some conclusions. Okay, let's see this particular statement. Especially this statement is timely with respect to COVID pandemic. Life is larger than engineering. Life is larger than even science and engineering also. And there is much more to education than engineering. You please see this very carefully. Education is the single most important factor in the development of a country. See, this education word, you can see presently what is happening in Kerala. Kerala is highly educated state. That's the reason the number of COVID cases are very less. People are listening, people are reading, people are understanding. That's the reason they are taking care. But the same is not with other states. Okay, that's the reason, very, very important. One has to understand how much education one should have in order to take care of everything. In that sense, I have given this statement. Another one, please remember one thing. Everybody has challenges in life to face. Only problem with the people is how are you going to identify the challenges? Then what is the definition of challenge? Basically, in order to enjoy life, you have to overcome the challenge. Then only. See, take for example, what is the challenge with respect to this COVID pandemic? A lot of challenges are there. Nobody knows what to do. That is the reason these numbers are increasing. Anyway, nothing great was ever achieved without enthusiasm. Enthusiasm is a must in order to understand happenings in the science, or in order to do something in science, or in order to do something in engineering. With respect to, these are the definition of engineering and science. The science is the study of what is. Basically, in engineering, you are creating new things. Or basically, what are you doing in engineering? We are going to build what will be. The central activity of engineering is the design of new devices, processes, and systems. The right now my talk is connected with the systems. You can have new devices, you can have new processes or systems. Anything we are doing in engineering, they have to fall in these three categories. The first one is the devices, second one is the processes, third one is the system. With this, we will see few definitions related to research, challenge, decision, and progress. Anyway, what do you mean by research? Research is trying something new with the hope that it is useful to the society as a whole. Otherwise, you can have the definition something like this: doing something new with passion, purpose, pride, and self-esteem, with the hope that it is, or it will be useful to humans and non-humans. Otherwise, what you have to do? You have to do existing stuff by different means with passion, purpose, pride, and self-esteem, with the hope that it enhances the living standards of humans and non-humans. This is very, very important. Then what is challenge? It is a simple definition of challenge. It is a situation where the task at hand seems to be bigger than the available capacity. How are you going to overcome? You can use this definition of challenge with respect to present COVID pandemic. Then challenge gives meaning to life. Then what is life after all? Life is a game of timing. You have to challenge your imagination, but don't imagine too much. Too much imagination is of no use in engineering. But basically, you have to challenge your imagination. Literally, you're going to get solution to all the problems. Invariably, in engineering, we are going to make a lot of decisions. Decision is equal to emotions plus logic. Basically, emotions make you to act. The logic makes you to think. That is what the combination. What do you mean by success? In engineering, you have to do a lot of research. Then you have to do a lot of development. You have to have a lot of progress. Once you have everything, you're going to create wealth. Okay, once you have everything, then you can say you are a successful engineer. What do you mean by success? Success is basically a choice of successive positive decision. Already have defined what is decision. You have to have a successive positive decision, then only you will be successful. With this, we will move on to the three different dimensions of academic research. Community will be there. As part of community, we will be there like a person, maybe scientist, engineers, social scientist, whatever. And then you will going to create knowledge. That is what is your knowledge. And then that knowledge will be going to get some meaning when you publish in the good journal. Many a times you're going to create a controversy, or sometimes you will accept at least I don't know something. At least accepting I don't know something itself is also a type of knowledge. Okay. And then why you do research? First of all, what is the objective or aim of doing research? First of all, I want to become top-notch researcher, or else I want to do something great for our country. That is how the aim and objective will be there. Specifically to see the specific objectives of our research, basically to experience the sheer joy of research, that too through happiness, ecstasy, and delight. The second one, to share this joy with a fellow researcher, to inspire future generation to pursue this career. This is also very, very important. You have to bring in young generation to continue this particular profession. For publishing new findings for name and fame, anyway, people are doing, even in IIT, they are doing. Improving the designs. Even though you are not going to create new knowledge, at least you have to improve the existing design methods to the correctly known procedures. That is also very, very important. That's the reason I have given second definition of research like that. Then lastly, for well-being of fellow countrymen and women. And then you have to do something for non-humans, because we are depending heavily on the non-humans. Okay, these are the objectives of carrying out research. And then this is what I already mentioned. Our outcome of research will going to get some value when you publish in good journals. Okay, research means a lot of thinking is involved. The productive thinking is also called as research. Thinking clearly and effectively is the greatest asset of any human being. One has to think properly. If you are thinking improperly, then you see what will happen to someone. Okay, and then how can I develop my thinking? Yes, you can develop your thinking abilities. That is possible. You don't have to blame your life or your birth itself. Don't expect everybody will going to get everything along with the birth. Then how can I develop or generate ideas? That is also possible. You can identify your problem, you can formulate. For
There is some technical issue. We will continue in a minute. Sorry for the inconvenience.
anyway, we have engineering geology, that is a subject in civil engineering. But all these fields of specialization in the world have come from earth sciences. Whatever we are doing in science as well as in engineering, they are supposed to be the part of earth sciences. Anyway, we are bit in the earth sciences. Okay, with this we'll move on to the big picture related to earthquake engineering. Let's say I want to know the response of this particular structure. It may be a bridge, it may be some structure or something else. Basically, you need to characterize your soil in and around your structure, maybe within 100 meters. And then if it is subjected to earthquake loading, earthquake is going to come somewhere, that is called earthquake source. These are the terms associated with earthquake source. And then from the source to the site of interest, that energy has to be propagated in the form of seismic waves. Basically, the seismic waves are the agents of energy transportation. Basically, energy will be released here. That energy has to be transported. They will going to come and hit your structure. Then you have to analyze. Then you will going to talk a little bit about wave propagation later. Okay, what is geotechnical engineering? It is a simple definition. Basically, it is concerned with the engineering behavior of earth materials. When you talk about structures of geotechnical engineering, these are all coming under structures of geotechnical engineering. Then, how do geotechnical engineers miss the big picture? Most of the times, we don't know what is the big picture. Big picture in the sense you have to have a comprehensive and qualified understanding of everything before attempting to solve any problem in geotechnical engineering. That sense, you please take this question. First of all, you have to understand what is the biggest problem. How do you solve the biggest problem? That we will see later. First of all, you have to identify what is the biggest problem. Once you identify properly, there are many experts or there are many software tools. How are you going to solve the biggest problem? Let's see. Now we will see the sustainable development. Anyway, development has to take place, but the development has to take place in the sustainable manner. With respect to that, this is a statement given by Einstein 70 years back. We shall require a substantially new manner of thinking if mankind is to survive. You just see the seeds of this sustainability have been shown at that time only. It is our duty to understand the meaning in between these words. Okay, what do you mean by sustainability or sustainable development? It is a comprehensive definition. It is a concept describing mankind's ability to create a world for humans and non-humans that environmentally, socially, and economically provides for a current population needs without damaging the ability of future generation to take care of themselves. This is very, very important. Basically, if you put this definition in the simple terms, you have to enjoy enough. You can allow others to enjoy enough. Then finally, you have to keep enough for the future generation to take care of themselves. That is what is the definition of sustainability. With respect to habitat and sustainable development, you have to have, this is a Venn diagram related to sustainable development. Anything sustainable, it has to be bearable. That is basically intersection between society and environment. And also it is supposed to be equitable. That means it is the intersection of society and then economy. Even though the sustainable anything is not viable, start with improved research methods or improved understanding about the processes and systems, one can make any development as a sustainable development. Okay, then how to handle this? Basically, you have to jump in the environmental design. There are two things in this. One, design for environment. Usually, you will talk in terms of 10, 20, or 30 years. Now, anyway, it is also outdated. You have to go for a design for sustainability. Anything you do on ground, definitely you're going to have some impact on the environment. The impact is very small. The environment will take care. You're not going to have the lasting impact. If your impact will be too much, then you're going to damage the environment. That is the reason one has to be very careful. Even though you are going for foundation design, please think of minimum more than 100 years, or even think of even 500 years, especially when you are building temples or creating some historical constructions or legacy for the future generation. Then what is development? I hope you know what is development. Let's assume you have got degrees from BTech to MTech, MTech to PhD. No doubt it is a development, but the development has to lead to progress. That progress has to lead to wealth. Then only it is called development, otherwise it's not a development. Development, maybe it is having progress plus wealth inside. What is urban development? Nowadays, we are talking a lot about urban development and sustainable urban development. If at all you want to know more about sustainable urban development, you please see this book. This book is available online. You just Google, you're going to get what makes a sustainable city. Similarly, you may be knowing what makes a city. Already you know city life. And then similarly, what makes a village? Then what makes a sustainable village? That one has to think whenever you are going to have such type of pandemics. Okay. And then with respect to the sustainable development, these are my definitions of engineering. This is the definition of engineering. Application of scientific principles to the solution of particular problems in a safe, efficient, and economic manner. Otherwise, simple definition follows like this. An activity concerned with the creation of new systems for the benefit of mankind. That activity proceeds by way of research. That is what is your PhD or postdoc. Then that proceeds by way of design. That is what your MTech. Minimum design has to happen in MTech. And then development. Basically, what is available that you are going to teach to our BTech student. The design, this is a comprehensive definition of design. Creation of physically consumable systems for the benefit of mankind by using the principles and the results of known methods of analysis, either by straightforward way or by using iterative procedures. Even if you don't want to know this design cannot happen in single go. It may happen for something, simple things in single go. Otherwise, it is the application of results of known methods of analysis is the design. Okay, with this we'll move on to the foundation engineering definition, because my topic is a subtopic of foundation engineering. Basically, what are you doing in foundation engineering? It basically applies geology, soil mechanics, and mechanics, and structural engineering to the design and construction. You please see this very carefully. Analysis is a part of design. Design and construction of foundations for civil engineering and other structures. If you think of any other structures, you can put under this. The foundation engineer, but this is very, very important role of foundation engineer, must be able to predict the performance or response of the foundation soil or rock to the loads imposed by the structure. How that actually soil takes the structural load, or how it gets distributed inside the soil with satisfying the design criteria. Then with respect to foundation design, foundation engineer must possess working knowledge in each of these three areas. Structural engineering, you have to know a little bit about structural engineering. Even though you are not doing anything, at least you should know how the structural engineers are going to evaluate the loading at the foundation level. And then you have to think of how to design foundation, not only with the geotechnical considerations as well as the structural consideration. Anyway, you have to understand the principle and design methods of geotechnical engineering, and then little bit about construction engineering. Let's assume you have design foundation. If nobody is coming forward after raising the contract documents, then you can think of, that means your structure is so complicated with the existing tools or whatever methodology is available in India, it's not possible. That's the reason we have to understand the construction engineering little bit. Okay, with this we'll move on. This is what is the big...
Sir, sorry to interrupt. Participants are feeling little fast.
Okay, no. Basically, these slides are very simple. They are all self-explanatory. That's the reason they should be very fast. The new generation will be much faster than us. That's the reason I have given. No problem. I'll go slow. Don't worry. Okay. 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 Dear students or participants, please this is the role and scope of foundation engineering. or geotechnical engineering, or you can say it is a ground engineering. An understanding of geological structures, this is also very, very important. Let's assume unknowingly you have put important structure on fault. Then you think of, after construction of 100-story, in 120-story building, what you are going to do it. There are many ways how to remedy the situation. An understanding of geological structures, materials and processes, combined with systematic application of investigative, scientific and mathematical techniques to produce practical solutions to ground related problems for the benefit of society. Whatever you do, you simply go out and literally watch construction activities with little understanding about the geotechnical engineering. You'll understand the role and scope of the foundation engineering. These are the general types of problems encountered by engineers, basically design. If you don't know design methods, you're not going to do any design. Then even though you have a design, in order to check whether design is properly designed or not, for that reason you have to understand something. Then how are you going to rate? Let's assume you are just a computer science engineer. You want to purchase a house in Chennai. How are you going to purchase? You have to rate that building depending on the age of your building, depending on the type of materials used, depending on the type of analysis methods used in order to create that particular design. For that reason, one has to have a lot of understanding. In that sense, I have given. Then design and design processes are related, intensely related. What do you mean by design? I already said it is another definition of design, is a process by which an optimum solution is obtained. Solution is supposed to be optimum. You don't have to go for 100% optimum solution. In any design, certain criteria must be established to evaluate whether or not an optimum design has been achieved. Basically, if you talk about shallow foundation or deep foundation, you have to satisfy the bearing capacity requirement, as well as your settlement should be well within the allowable limit. That is how we're going to satisfy the design criteria. Okay, with respect to this particular foundation, it is called as a combined file raft foundation. This is a raft, these are the piles. In this case, what will happen? If you are not allowing the raft to transfer any load, in that case, it is called as a pile cap. Simply pile cap transfer the structural load coming from the column through pile cap to the whatever your piles and all. If you are allowing certain amount of structural loading is transferred via raft with a direct contact with the soil, in that case, it is called as a combined file raft foundation. Let us assume F total is a total load coming on your structure. The resistance is coming because of your pile. Pile has two types of resistance. One is a tip. This is what is your skin. And then you will going to have resistance offered by, because of this pressure, your total resistance offered by combined CPRF should be much higher than your F total. That is what is your structure load. Load is supposed to be less than or equal to resistance. This philosophy one has to use in order to satisfy any criteria. Okay, design procedure. Basically, it is an iterative procedure. These are the some of the ingredients of iterative design procedure. Start with planning. Then you have to have primary structural configuration, establishment of the loads. For that, you have to depend on the IS codes or some other codes. Then you have to select preliminary member selections. Then you have to perform analysis, evaluate, redesign. Basically, here you are going to use the loop. Then finally, you will go for final decision. While making final decision, you are going to make use of intuitive ability of the experienced engineer. Okay, building and design codes are equally important. Whenever you want to build something, you have to follow the design codes, relevant design codes. The design codes are not ultimate, or they may not be much wiser than your engineer. In case you don't have any design codes, people won't follow any rules or regulations. Otherwise, they will going to put the public in danger. That's the reason. In order to protect public from the excessive damage due to not following the codes, that's the reason one has to follow the codes. Okay, what do you mean by design? Design means it has to satisfy certain loading for the designated time or under certain environmental conditions. Take for example, I'm going to talk earthquake resistant design. You are going to speculate certain earthquake loading. You use that loading, then you're going to proportion all the building elements. Then you're going to concept the structure as a system. If at all that structure is subjected to that particular loading, it should behave the way you intended. Then you can say the structure has been designed properly. Okay, how does one assess the acceptability of engineering design? There is no single answer for this. It varies from person to person. In case you have a lot of uncertainties, even in your soil report, if you have a lot of uncertainties in the properties of your structural materials, then what you have to do, you have to quantify the uncertainty. You have to propagate those uncertainty using probabilistic reliability analysis. In case you want to do little more in earthquake engineering, then we will going to follow the term called performance-based design. Then this is what, how complicated does it need to be? It should not be too complicated. Otherwise, others will not understand. Especially at least 50% of understanding should be there for the engineer who is constructing on field. That means you have to keep that complexity within that limit. Anyway, this I already told. Application of results of known methods of analysis is a design. Now, these are the different foundation system. Here we have shallow foundation. The raft is also shallow foundation. Sometimes you have a pile foundation or plunger piles. This is what is our pile raft. These are the different options for foundations. If the ground is perfectly all right, you can bearing on natural ground. Otherwise, you can replace the ground and then can fill with the good material, or else you can have the compacted, consolidated ground, or else you can have a composite ground, maybe foundation on stone columns. Then you can go ahead. Otherwise, what you have to have, if you have a very soft or weak soil beneath the ground, then you have to bypass using these solid inclusions called pile foundation. Okay, this is what we have already seen. It is a pile supported structure. When you talk about pile raft foundation, let's assume it is a raft. These are the piles. Okay, I want to transfer the structural load as per a static analysis and design of PRF, pile raft foundation is concerned. What is the big picture? The big picture is simply load versus settlement. That's all. As per a static analysis is concerned, depending on your understanding of the soil structure interaction effects, you can decide. You can keep your pile and raft together under elastic. Then you can leave here at this level. This is what is your allowable settlement. This is what is your allowable load on the structure. In case you want to make use of your piles at working load, that means serviceability load, you can increase certain loading. One has to be very, very careful. Sometimes you will be somewhere here. That means this will be 10% of this one or 20% of this line. That means basically you are using effectively your solid inclusions under serviceability loading. And dynamic loadings are concerned, you have to get this loading under the cyclic loading. Basically, you're going to consider the degradation in material properties. Then you have to choose accordingly the analysis procedures. Okay, a few books, especially for the youngs one. This is the best book by Holds and others. This is by Pati Ajeji. And they all are available online. This is Shallow Foundation. It is the most comprehensive book available right now. And then the foundation design, it is the most, this is also most comprehensive, talking both shallow and deep foundation, even soil exploration. This is analysis and design of shallow and deep foundation by Rees. I have used this book in order to get something later, I'll show you. And then this is a pile design and construction practice by Tomlinson and Woodward. This is tall building foundation design. Especially in this book, 5 case studies have been described using PRF concept. That means piled out foundation concept. And then if at all you want to understand the constitutive models, basically stress strain relation, this is the most comprehensive book recently published by CRC Press. This is also available. And then this is advanced geotechnical engineering. Here they have considered a lot of soil structure interaction effects written by Desai and Jaman. If at all you want to understand finite element, start with this is what is the linear finite element book by Jane Reddy. This is also linear. Okay, this is also really very good from the American perspective. And then if at all you want to understand non-linear finite element analysis procedures applicable to solids and structures, one can refer this book. Of course, we have a Zinkiewicz book also. The Zinkiewicz book a little bit advanced. Only after studying from simple books, please jump into that. Okay, what do you mean by mathematical modeling? And then what is finite element? Anyway, mathematical modeling, you will going to get the differential equations. Invariably, you will end up getting differential equations most of the times. Then in order to solve differential equations, there are a number of techniques, but the FEM is more powerful and it is also most important contributions of the last century. How are you going to study concisely? Okay, I want to tell you, I want to become expert in soil structure interaction. First of all, you have to understand the soil structure interaction effects. Then how the soil structure interaction effects will going to govern the behavior of your foundation as well as structure. For that, you have to have certain background and historical know. Let's assume the soil structure interaction have a lot of effects you have disregarded during analysis and design. What will happen if you erect that structure on ground? Okay, definitely you're going to see some severe damages or collapse. Then some idea or concept has to be there. And then you have to talk about the principle. Principles are very, very important. Once you have principle based on certain approximations and then assumptions, you can develop. From there, you're going to get the theory. Theory means most of the times these are equations. That too in our geotechnical and structural engineering, these are differential equations. Once you have equations, simply you have to solve. Before putting those solutions on ground, you have to validate using experiment. You may be thinking, why are you doing all these things? In order to do something for society. When you do something for society, you have to practice with ethics. This is very, very important. Now I want to tell you with respect to one geotechnical engineering example. Let's say I want to create a reservoir. You know what is a reservoir? Basically, I want to store that to using earth dam. Okay, the moment you consider earth dam, enemy water will seep through. In order to know how much quantity of water is seeping through, you have to have some differential equation that is called your Laplace equation. When you talk about a principle associated with that, that is what is V is equal to Ki, that is what is your Darcy law. Then you're going to have physical system. Then you're going to reduce that physical system with certain assumptions and then simplifications. You're going to get the theory. That is what is your Laplace equation. If the flow is steady state, otherwise you're going to get the Poisson equation. Already that equation has been solved. Already so many dams have been built. They are performing very well. That is how you can keep any topic here. You can follow these sub ingredients so that you can understand. Okay, what do you mean by mathematical modeling? I have a physical system. Literally, you cannot do. If you have a lot of money, you can do experiment in 1G scale. Even if you don't have enough money, you can reduce maybe half scale or maybe 1/10 or 1/50th. Then you can perform. Then you can use the dimensional similitude. Then you can predict the behavior of prototype in the field. Then go ahead and construct. Otherwise, what you have to do, you have to reduce the physical system to mathematical system. If the system is very simple, you can use existing solution methods. Then you can go ahead. If the system is so complicated, take for example, pile supported 200-story building resting on layered soil with a lot of faults in the ground. Then how are you going to solve? Anyway, you have to develop the complicated loading arrangement, boundary conditions. You have to characterize the soil properly. Then you're going to have the differential equation. When you talk about finite element basically solves the differential equation. Then you have to go for numerical system. Now we'll see how are you going to develop. This is the schematic of mathematical modeling of a physical process. We'll start with the physical process or a problem. Then you will identify important variables. Then you will go to make reasonable assumptions and approximations. Then here we will going to apply the relevant physical laws. I want to tell you one of the physical laws here. You have already seen F is equal to ma. It's the Newton's second law of motion. Where you are using this one. In order to analyze your structure for dynamic loading, fixed base structure subjected to earthquake loading, you can simply make use of mx double dot cx dot plus kx is equal to minus m times ground acceleration. In order to derive this equation, basically you have made n number of assumption, and then you have made use of F is equal to ma. That is what is the principle. This differential equation itself is a theory. That itself is a differential equation. If it is a simple, yes, you can apply the applicable solution technique. Then you have to apply boundary and initial condition. Get the solution. Only thing, the solution has to be understood with the proper knowledge of your physical system. That's it. Then basically you are addressing all these questions as part of mathematical modeling. Only thing what you have to see here, is there a relation between the type of physical process considered and the equations that result? This is very, very important. You can see this particularly to understand. Steady state C page, basically you're going to get the Laplace equation. You may be using H there, del square H by del X square, something like that. It is a general field variable. As far as consolidation is concerned, you have this equation. Anyway, you have a CV here, coefficient of consolidation. As far as one dimensional wave equation, you have some coefficient. In order to analyze frequency of your footing or foundation, one has to go for generalized eigenvalue problem. If you set, you will going to get mx or mu double dot plus ku is equal to 0. You will going to solve, you will going to get a set of frequencies corresponding to each of the frequency. You will going to get the mode shape. Then you will analyze your building accordingly. Okay. Basically, your continuum mechanics. I hope you may be knowing what is this subject. Continuum mechanics is the birthplace of mathematical models. Why study finite element? Once you have differential equation, you can use any number of methods, but finite element is very powerful. That is the reason one has to go for finite element. This is the big picture about finite element. You can do physical modeling, maybe 1G or NG. Still, you can predict the behavior of your actual structure, then erect the structure. Otherwise, you can use numerical modeling like finite element. But finite element requires constitutive models. These constitutive models have to be verified by performing the element test. I hope you know we are doing a lot of element test in the lab. With that, you will going to get the parameters of the constitutive model. There are few questions associated with the finite element analysis. How is a geotechnical finite element analysis set up? You can put your structural engineering or even water resource or environment. How is a structural finite element analysis set up? That I hope you may be knowing using your SAP or STADPRO. And then how are constitutive models selected? This is very, very important. You have to understand the structural loading, type of your subsurface profile, those properties. Then you're going to decide whether the linear constitutive model is okay or non-linear or advanced constitutive models are required. And then how are soil and rock parameters are obtained? For that, anyway, you have to perform a laboratory and field experiment. Then how are geotechnical structures model? How are you going to model your structure? Anyway, you know, how are you going to model or how are you going to choose the constitutive models for structural materials? In case you suspect interaction effects are there, how are you going to consider the soil structure interaction effect? Then can FE analysis be used with the design codes? Yes, right now you can use. In STADPRO, you have almost all the codes. Then you can address all these limit state requirements. Okay, I hope you have already seen this building, maybe in some newspaper or maybe in some magazine. This is the highest high-rise building right now in the world. That is Burj Khalifa. It is more than 800 meters high. I want to tell you the ability of your finite element analysis. These are the finite element results. These are actual results coming from the load test conducted by Haider Consulting. See the maximum load on the, this is the maximum load on the pile head, that is 60 meganewton. Corresponding maximum moment or pile head displacement is 2.2. Finite element is able to touch the maximum 60 meganewton as well as the settlement obtained is 2.6. Invariably, finite element has to give little higher deflection or settlement, the lesser load. Perfectly all right. These analyses have been performed in Germany. Along with the construction, design principles are equally important. I have touched a little bit about. During construction, one has to monitor. During monitor, you have to make a lot of decisions, making use of this observational method. Anyway, you are monitoring. Based on monitoring, you are going to get the settlement information or whatever. Then you have a computational tool. Literally, you have to play in the computer. After considering 10 story, what are the settlements? After considering 20 story, you compare. If at all any action is necessary, if you are not defined your loading properly or your building process, basically how are you going to construct? One should not erect anything on ground in 1 day or 2 days. You have to understand the settlement behavior of your soil. Accordingly, you have to decide the rate of loading, basically rate of erection of your number of stories. That is how we will going to make use of this observation method. But one has to be very careful when you are using analysis, especially numerical analysis tools. You have to understand quality control and assurance is also very, very important during construction. Then comes the soil file structure interaction. I want to touch upon a little bit basics regarding kinematic interaction, inertial interaction, simple analysis of soil structure interaction, how one has to perform using SAP and STADFlow. What are the effects? You please understand the effects. If you don't consider what will happen, if you consider what will happen, then with respect to soil file structure interaction analysis, I'll talk a little bit about deep foundation. Then I want to tell a little bit about how are you going to analyze your single file for shaft behavior. That means shaft and tip. Then analysis of single files for lateral loading. Then different forms of loading, and then pile group. Then analysis, and then a little bit about the conclusions and remarks. You see this particularly, this is the same structure found on rock elsewhere, maybe one in Chennai, one maybe in Trivandrum. If the rock almost properties are same, structure is exactly same, behavior is exactly same. Let's see what will happen. If this structure is supported on soil, how does the presence of soil affect the response of structure? Definitely. In the left hand case, you can assume it is a fixed base structure. If the rock is having more than 1000 meter per second as shear by velocity, that will going to tell indirectly the stiffness of the rock. Does the structure founded on rock respond differently than when founded on soil? Definitely, they are going to found. It is because of the compliance of soil. The stiffness of soil is not equivalent to stiffness of your structure. That is the reason one has to consider the soil structure interaction. Okay, these are some definitions. Let's assume you don't have any structure. Okay, it is subjected to earthquake ground motion. If you are going to record through some recording instrument, basically variation of acceleration with respect to time, it is called as a free field motion. Basically, it is a shear free surface. If you have a foundation, if you are able to record the motion at this level, it is called as a foundation input motion. It is also called as FIM. Basically, you have a 3 translation and 3 rotations. Okay. How does the motion at the base of the structure differ from the free field? Definitely because of the confinement effect, you are going to have the different input motion here. That is the reason it is called as foundation input motion. If it is subjected to earthquake loading, your soil profile. If you have an instrument, it is called as a free field ground motion due to propagating seismic phase. Let's assume you have structure founded on certain foundation. This is what is your ground motion at the building. If you are treating it as the fixed base, if you are little far off, let's assume you are 100 meter away. Here you are going to have the free field response. When you are close to your building, this motion is influenced by presence of your building. That also you have to be very, very careful. If the structures are closely constructed and they are very tall, then you have to be very, very careful. If at all you want to get the response, basically you are going to get the response, basically acceleration at the building top or wherever you want. Once you know the response, you can literally evaluate all force resultants or even deformations in the building. Okay, what is the definition of soil structure interaction? This is the definition. The response of the soil affects the response of structure, and the response of the structure affects the response of the soil. This mutual interaction effect is called as soil structure interaction. Over the years, soil structure interaction effects have been studied under 2 headings. These are the 2: kinematic interaction, inertial interaction. Now there is no point in going for kinematic interaction, inertial interaction separately and adding together. Because of powerful softwares, one can attempt all these in single go. Just for the explanation, I'm going to explain here. What do you mean by kinematic interaction? Presence of stiff foundation elements on or in soil cause foundation motions to deviate from free field motions. The moment if you don't have anything in the ground, you are going to have the free field motion. The moment you put your foundation, even though you are disregarding the mass of your foundation, but you have to consider the stiffness and symmetry of your foundation as well as the soil, you are going to get the different free field motion. That is called as kinematic interaction. Basically, you are going to get FIM. Inertial response of structure causes base shear and moments. The moment you vibrate your structure, in turn those vibrations will pass to the foundation in the form of shear and bending moments, which in turn cause displacements of foundation relative to free field. These things you have to address. How are you going to handle? What are the effects of kinematic interaction? These are the three effects. First one is the base slab averaging. It is coming because of stiffness of foundation. Another one is the embedment. Basically, let's assume you have a pile foundation. Okay, embedment, basically variation of ground motion with depth. Take for example, you have a pile of length 30 meter. Okay, how your ground motion is going to vary all along the length of your pile. Take for example, you have a shallow foundation, thickness is hardly 2 or 3 meter raft. Even that case also ground motion is going to vary. How are you going to quantify? Let's assume earthquake or basically waves will come and hit at the corner. What will happen to the intensity of your ground motion? If your incoming ground motion may be having high frequency content or low frequency content, what are the effects of wave scattering? Let's see what will happen. Okay, this is what is the wave motion. This is what is your foundation. Basically, what will happen because of the presence of stiffness, you will going to have the base slab averaging. Even it exists for the massless foundation. Basically, what will happen? You will never going to have the matching pre-filled response as well as the response of your foundation. Then coming to flexible file, let's assume you are this is the response of your ground. Okay, I have a flexible file. You're going to bend according to your wave motion. Basically, what will happen here? What are the interpretation coming out of this? Deformation matches with the free field. Whatever deformation without pile you have, then with pile, both deformations are exactly same. What is the meaning of that? Surface motion is equal to free field motion. No rotation at the surface. Basically, you cannot see any rotation. Now you see what will happen if you have a rigid file in the same medium. See basically what will happen to the deformation of a rigid file. Deformation different than free field deformation. Can translate and rotate. Basically, the file can move and then it can rotate. The interpretation is surface motion is not equal to free field motion. Rotation and displacements of free surface, you have to cater for this. Okay, that means you will going to have the different bending moment requirement all along depth of your foundation. Okay, now reduction of ground motion. This is with respect to embedment. Now you can see basically what will happen. You just see carefully the amplitude of this one. The amplitude is keep on decreasing with respect to depth. Okay, next you see what will happen here. Okay, even with respect to particularly propagating shear waves also you are going to have the successively decreasing amplitude when that wave comes and hits the ground surface. Okay, particularly propagating shear waves can cause rocking as well as translation. You can make out from this animation. Okay, the next one is a scattering, how the waves are getting scattered at the corner. Okay, the wave comes, hit the corner, this is how it is getting scattered. This is having important effect with respect to amplitude of high frequency components. Basically, it reduces the amplitude. That anyway you have to account for while analysis of kinematic interaction. Okay, how are you going to do the soil structure interaction? Or what is SSI? SSI basically results from the compliance of soil. Means soil is not going to have the stiffness more than your structure. That means you have to respect the stiffness of your soil. Then you will going to have the compliance. That means soil is not rigid. It will going to deform due to loads from the structure. How are you going to understand? Basically, you have three translations in case of 3D. Then you will going to have the three rotations like this. Then what is the relation between force and displacement? This is what is your stiffness matrix. It is also called as compliance or foundation compliance. In dynamics, the same is called as impedance function. Here we have three translations and then three rotations. They are related, like F is equal to Kx or M is equal to K theta. These are the rotational stiffness coefficients. Okay, in case of 2D, you have two directions, basically two translations and one rotation. This is what is our compliance or foundation compliance matrix. Then deformation resulting from structures will propagate away from structure in case of soil structure inertial interaction. See basically what will happen. When you vibrate your structure, the vibrations will be put back to the soil. Anyway, they will be taken back. That is called as radiation damping. Basically, energy is removed from the radiation damping. One should not consider. Only thing you have to have and far away from your foundation, the boundaries. Okay, then how are you going to analyze? There are two approaches. One is a direct. In that, we will go to model soil and structure together. This is what is your structure. This is what is your soil. Certain amount of soil has to be considered depending on width of your structure. You can decide where you are going to put the boundaries. Then you have to use a consistent boundaries or infinite or your transmitting boundaries here. This is what is your ground motion. Basically, it requires detailed model of soil and structure in single computer program. It can handle non-linearities in soil as well as in structure. With respect to substructure method, you can separate out. This is what is your kinematic soil structure interaction. This is what is your inertial. Then you can combine the responses so that you're going to get the total response of your soil structure system. Then what will happen here? You can use a different code for this. Then you can use different code for this. You can combine the response. With this, basically what are you doing? You are using principle of superposition. That means you are considering soil behavior as well as structure behavior linear. Okay, let's see how I am going to do the kinematic analysis of soil file structure system. Okay, basically what you have to do, you see this very carefully, subjected to earthquake, ground motion. Now you disregard the mass of your foundation, but consider the stiffness and geometry of your foundation as well as the geometry of your soil medium. Model foundation as massless with stiffness. Then you have to apply the ground motion and then see what will happen. Compute foundation input motion. With respect to this is a 2D structure we are idealizing. Actually, pile may be running perpendicular to the slide, maybe some numbers. You are going to get one rotation and then u theta fm means you have ux and uy as a function of time. That is how you're going to evaluate. Then you have to bring in your SSI and then you have analyze soil structure interaction effects. Okay, these are influenced by stiffness and geometry of soil and foundation. Please understand, this is a theory. You have to understand. That's the reason I put a title theory. Then applications will little later. Okay, how are you going to get the foundation impedance function? Impedance function equal to foundation stiffness and damping. In this function, you are going to have the stiffness as well as damping. With respect to vertical loading, you can replace your soil with these spring coefficients. This is what is your foundation impedance function for vertical loading. Similarly, for the horizontal loading, you have these coefficients. Similarly, for the moment loading, you have, especially for a 2D. With this, you can bring in your structure. Basically, you have all these 6x6. Then you can bring in your structure. You can analyze your soil using these spring coefficients. You can use SAP or STADFRO. You can perform soil structure interaction analysis. Based on principle of superposition, frequently performed using equivalent linear. Even though the soil and structural behavior is non-linear, you can use equivalent linear approach in order to analyze the response of your structure. Then if it is a fixed base structure, you can apply ground motion somewhere here. You can carry out hazard analysis in order to get this ground motion. If it is rest on soil, then you have to be very, very careful. Either you use the spring coefficients or you can divide the soil medium to number of finite element, apply the ground motion here, you can perform response of your structure. There are many ways. How are you going to get the ground motion? Let's assume you have ground motion on ground. You can follow deconvolution, get at the bedrock, same you transfer somewhere here. You perform the ground response analysis, basically solution of wave equation. You're going to get the motion at building. Then you can perform the response analysis of your structure. Basically, you are doing this. Basically, you are solving this one. In case of soil structure interaction, soil foundation structure interaction, you are basically solving this equation. You have to apply. This is what your control point. Then you have to have the proper boundaries. There may be artificial boundaries. You can allow this displacement to take place. Here you have to arrest both the displacements. Okay. Then in case you suspect linear soil layers are there, they have different properties, then you can use equivalent shear building model in order to get the output at the ground surface. You can use this as an input motion for your structure and then perform the soil structure interaction analysis. What are the effects? Basically, I want to tell you there is no time much. I'll quickly rush through and then I'll tell you as part of the final. Okay. Basically, you see what will happen. What are the effects of soil structure interaction? The explanation is given in the previous slides. With increased foundation flexibility. Flexibility means foundation stiffness is lesser than your structure. What will happen to your fundamental period or structural period? That increases. That means it is a lengthening that you can evaluate from this. This is the fundamental period with respect to consideration of fixed base. These are the stiffness associated with this single degree of freedom system. Okay, and then damping increases. This is what is your increased damping. This is the radiation damping. Depending on type of your structure, if you have a stiff soil, the soft structure, you can see whether it is going to have effect or not. In case you have a soft soil, stiff structure, definitely interaction effects are more. Those I have covered in the previous slide. SSI can decrease structural deformation. This particular point corresponds to structural deformation. Whether you consider SSI effects or not, this will be there. If you consider SSI effects, this will be little less, but total deformation will be more due to your translation as well as rocking. Okay, if at all you suspect soil amplification, you please account for that also in the analysis. This is a summary of the whatever so far I have covered. SSI is not significant for flexible structure on stiff soil. SSI can be quite significant for stiff structures founded on soft soil. Fundamental period of soil structure system is longer than fixed base structures. That's what I shown in the previous slide. That is a tilde. Effective damping of soil structure is higher than the damping of structure alone. You have to accept this one. The total displacements can be increased by SSI, can be important for closely spaced structure. Let's assume you have high-rise structures. They are closely spaced. If the soil structure impactions are predominant, then you have to be very, very careful. Otherwise, ponding will going to take place during earthquake loading. Neglecting SSI is equivalent to assuming the structure is supported on fixed or rigid material. This is as good as analysis of fixed base structures. Let's move on to the soil file structure interaction. Deep foundations are special with respect to these 2 points, in which the depth of foundation is very, very large with respect to width. Diameter of pile may be 1 meter. The length of pile may be 100 meter or 60 meter, which are not constructed by ordinary methods of open pit excavations. You have to be very, very careful. Pile foundations or drill shafts or well foundations, you have to go for specialized construction equipments. This is the load transfer mechanism between shallow foundation and deep foundation. And then this is what usually happens when you plot side friction and toe bearing. The side friction will be mobilized at lesser settlement. That's basically related to displacement between the pile and soil and pile shaft. Then toe bearing, anyway, you have to have more than 10% of pile diameter. This you have to evaluate on case by case basis. Usually piles are used in groups or any deep foundation element. Okay, why deep foundations? Because of poor soil conditions, or you want to bypass this weak material, one has to go for pile foundation or deep foundation, something like this. It may be subjected to this type of loading. If you consider single file, it may be still subjected to this type of loading in case of 2D analysis. Then little bit about design. How are you going to get allowable load on single file? If you have separately factor of safety on the shaft resistance, you can use 1.5. Then end bearing, you can use 3. In case you are single factor of safety, you can use 2 or 2.5. In India, we are using 2.5. Then this is what is your file foundation. See the clarity. Okay, these are from America. And then see this. Please note this excavation outside. This has to be filled properly. Then only you can use this passive resistance offered by your pile cap. Similarly, the same note excavation outside forms. This is a drill shaft. Okay, this is a reinforcement case lowering. Then this is a concreting. Just before finishing the concreting, just see the clarity in construction. And then single file shaft wear. How are you going to determine the vertical load carrying capacity? This is applied loading in downward direction. This will be registered by skin friction and tip resistance. Basically, it is high in clays, low in sand. Similarly, it is the reverse here. Okay. And then if it is subjected to uplift loading, it is registered by skin friction. In case of clay, if you have some suction, that will be active in that case. Otherwise, one should not consider a suction. Okay. And then how do you measure the vertical load resistance? You have to instrument using this. Otherwise, you can perform file load test, or else you can do finite element simulation in order to get the load deflection curve. Basically, how are you going to get this one? You have to put the strain gauges, apply the load in parts. Let's assume Q ultimate is there, that you are applying in 1/5. First you apply, the 1/5 of that load is entirely taken by the shaft. Then you increase, then the shaft resistance is mobilized. A part of the end bearing will come into picture. Then you increase further. When it touches the ultimate, then your end bearing as well as your kin friction, both are mobilized. Your Q ultimate is equal to tip resistance plus skin resistance. Then you have to apply the factor of safety so that you're going to get the allowable load on single file. This is what is your pile head displacement and pile head load. Okay, this is what. Now you see here, it is a non-linear. Non-linear means you will going to have the different stiffnesses. That means non-linear behavior. That means stiffness is not constant. That is what is given over here. You can just see. These are the different stiffness values. Non-linear soil response means pile stiffness is not constant. Same is going to happen to the lateral loading. Okay, without loading, this is how you will be having the lateral load on the pile. The moment you apply the lateral load, the soil is going to apply some resistance. It is going to offer some resistance. That's called as a P. It is a soil resistance. Then this is why your pile deflection. Basically, displacement of pile in the soil. These are also called as PY curves. So basically, what will happen? This is what is your PY curve. This part is stiffness, slope of the initial curve, and then you're going to get the strength. Please understand the difference between strength and stiffness here. Then at large depth, basically what will happen? You'll feel as if soil is going to move around the pile. Then there are n number of solutions available for P ultimate. How are you going to get it? Then at the shallow depth, basically this portion will be lifted up and then moved laterally. That's what happened. Basically, you're going to have the two components, vertical and horizontal. If the pile is in this plain ground, if it is subjected to same lateral loading on both the sides, you're going to have the same response. That is what is given over here. Symmetric loading means symmetric response. Let's assume pile is in sloping ground. If you are subjected to lateral loading in this direction, the resistance offered by this part of the slope, this upslope is tremendous compared to the downslope direction. You have to appreciate, you have to provide for in the analysis. And then how are you going to get the PY behavior? Basically, you have to perform the lateral load. Only thing you have to have the strain gauges on either side here. Anyway, lateral load. Let's assume you have designed your file foundation for axial loading. If you have designed properly, the 20% of your axial load is equal to your lateral load. If it is well within your lateral load coming because of your earthquake loading or some wind loading, you don't have to do extra analysis. If it is more than that, you have to perform explicitly lateral load analysis. That is how you're going to get. I hope you know this equation. If you solve this, you're going to get the bending moment. From the bending moment, you can get the shear force. From this, you're going to get the variation of your P. Once you apply certain loading, you're going to get this one P. The moment you increase, you'll get another P. Similarly, variation of bending moment and shear force. Then you're going to get the complete non-linear PY curve. Here also it is a non-linear. Non-linear means lateral stiffness is not constant. There are n number of PY curves available for sand in case of static and cyclic loading. In stiff clay, similarly for static and cyclic loading. Similarly for soft clay. These are the ready-made solutions available for us. These are all available in IS codes. One can refer the American Petroleum Institute Code 1993. Recently it has been revised. Depending on type of your sand, or type of soil, or type of loading static, you can get all these PY curves. That is how you can quantify. Basically, you can see from this, it is a rate dependent. Basically, what will happen? It increases with increasing velocity. If you are performing experiment in the lab with increased strain rate, you are going to get higher values for P and Y. Okay, that means it implies frequency dependence in dynamic analysis. Basically, I want to take you from the static loading to the dynamic analysis. From here, I'm going to modify all these curves for the dynamic loading. That means you have to respect. It implies frequency dependence in dynamic. That means all these are dependent on frequency. Somehow you have to bring that. Okay, and then how I'm going to analyze single file? This is what is the differential equation. This is a theory for single foundation subjected to lateral loading. That too on the dynamic beam on non-linear Winkler foundation. Basically, what I'm going to do, near the soil, I'm going to consider the near field. Here, non-linear inelastic effects will be there. This is a far field, the linear elasticity will be there. If you move far off, then you're going to have the free field displacement. This displacement is not affected by the presence of your foundation. Okay, how are you going to represent the near field? This is how you can represent using when multiple springs and multiple dashboards you can use. This is what your MNF near field. Similarly, 1 by 2 because of single spring. That's why you are getting this mass matrix. Okay, this is what is your stress strain or behavior with respect to or constitutive behavior for this spring. Similarly, for dashboard element, this is what your constitutive relation. Then frequency dependent radiation damping is taking place in far field element. This you have to appreciate. Okay, and then how are you going to represent the far field? You're going to use the multiple stacks of springs and dashboards. Similarly, you're going to make use of the stress strain behavior or load displacement behavior. Here you are going to have the far field displacement or acceleration or whatever. This you have to apply in the analysis of your file subjected to lateral loading. Then there are many charts available in order to get the foundation impedance function. Basically, stiffness plus imaginary part is due to damping. This is the dimensionless frequency. Then see basically how I'm going to get for this skin resistance. You can make use of TZ curves. These are standard curves available. What about tip resistance? You can use a QZ. What about lateral resistance? You can use PY curves. Okay, these are the forms of loading. If you have vertical loading, you are going to have TZ and QZ. If you have horizontal loading, you have a PY. If you have diagonal loading, then you're going to have the rotational springs. Okay, what will happen if the pile is there subject to vertical loading in the layered soil? This is what exactly happens. Okay, then here you're going to have the tip resistance. Vertical stiffness. Basically, this stiffness is governed by the entire soil profile above. Okay, if it is subject to lateral loading, what will happen? Now, see basically what happens. This is how we're going to get the reflected shape. The resistance is governed by the soil in and around the pile. That's the reason we are compacting the soil in and around little depth and little away from the pile. Okay, deeper soils may not contribute much to the lateral loading. And then how are you going to evaluate the stiffnesses for static loading for single file? The pile is in uniform soil where you have a ES constant. Then you have to apply, you have to understand some structural analysis concept, KHH, that means linear, you have applied 1 unit, then you're going to get what is the rotational stiffness, that is KMH. Then similarly, you apply unit rotation, then you look for what is KHM. These are the ready-made formulas available for the linear behavior of soil and structure. How are you going to get the KHH? Where D is the diameter, ES is the average, anyway average and ES star are same here. That is how we are going to construct the stiffness matrix for this particular soil profile. The rocking and swaying are coupled. If you consider they are 0, then you are not consider the coupling between swing and you are rocking. If you consider certain values for this, that means you are respecting the coupling between these two motions. Then Gibson's while it's basically linear variation of your Young's modulus. You can make use of these spring coefficients. You can evaluate. Only thing you have to consider this ES is the average Young's modulus. Then you have to get at respect to depth this ES. And then if it is subject, if your soil profile is varying like this, that means parabolic variation. These are the formulas for evaluation of spring coefficients. In case you have a layered soil, there are no ready-made solutions available. What you have to do, you have to perform the PY analysis. Then you have to get the stiffness coefficients. Okay. Then this is a little bit about what will happen if you have very flexible file. See basically what will happen. High curvatures, but still your bending moments are very low. You may be thinking curvature is more means bending moment is more. It is not like that because of the flexibility of your foundation. But flexural demands can be as high at depths as near the surface. If you are thinking flexural demands may not be there here, if you are not designing properly, if it is a layered soil here, your file may cut off here. Pile head motion and pre-filled motions are same here. In case of stiff file, curvatures, low curvatures, but bending moments are very high. You have to be very, very careful here. In case of stiff file, in the uniform soil, flexural demands can be high as depth as well as near the surface. And then in case of layered soil, see basically at the interface, high free field curvature at boundary. If you have not designed your file properly, what will happen? Basically, you're going to get this. This is actually after excavation, after subjected to earthquake loading. Literally, you have seen the piles have cut off. That means you have not designed your file for higher bending moment. That means you have not considered this in the analysis. Similarly, if the soft soil is embedded between stiff, Then what will happen here? See here, high pre-filled curvature at both the boundaries. See basically what happened, and then you see cut off at both the locations. These things you have to understand. Basically, it is a summary type, inertial interaction, kinematic. Sometimes you have lateral spreading or permanent deformations that you have to respect in the analysis of your soil friction interaction effects. All parts of loading are given. The spring coefficients are given over here. Then this is what, in case you have a liquefiable soil, just see basically what will happen. With increasing earthquake loading, soil is going to become softer. If it is a liquefiable soil, you're going to have, the shape is perfectly all right, but you will going to have the decrease in stiffness. That is how you're going to have the failure in liquefiable soil. Okay, this is what exactly happened. One can develop by conducting some tests like the blasting. Pre-blast, you're going to get the load versus deflection. Then after the blast, also you're going to get, because of the blast loading, you're going to have the number of cycles of loading. This is how the stiffness is going to decrease. Okay, and then pile groups, basically you have to understand this is what happens if it is subjected to lateral loading. Okay, basically these are the requirements. What will happen to your pile? Okay, I want to rush a little bit. I need only 10 minutes, please. Okay, if it is subjected to lateral loading, what are the terminology? These are the zones of influence. They not only influence line-wise as well as row-wise, and then not all piles produce same resistance in case of piles subjected to lateral loading. And then the pile-file interaction can affect group efficiency as well as stiffness. Because of this interaction, the group efficiency also will be less. Then the stiffness of a pile, this particular pile in presence of the surrounding pile will be less. That is the reason overall stiffness is less than the stiffness of the individual piles multiplied by the number of piles. Okay, piles interact at spacing. Basically, if your spacing is less than 7 and 8 times, this number is with respect to piles in the offshore constructions. On ground, if it is less than 5D, still you are going to have the interaction effect. Okay, then you see these are the row designations. The first row is called as a leading row. Second, third, and four are called trailing. This is the first trailing, second, and third rolling. Now we see basically what happened. Let's assume you have performed the numerical experiment. Then you could able to get the average load versus deflection. Single file is going to take a tremendous load as well as deflection. But the first row of piles determined using actual measurement as well as the group software. It is a software used to evaluate the pile head load versus deflection. Similarly, bending moment along the length of the file. See, the comparison is perfectly all right. This is the second row, third and fourth and fifth row. They are going to have exactly same load versus deflection. Okay, that's what is given over here. Okay, leading row takes maximum load, especially in the group. The trailing rows take less load. Then group effects handled by P multiplier. How are you going to handle? With this, you can develop the P multipliers. Those are given over here. Once your spacing is more than 6D, one should not consider. That means efficiency of your file foundation is very high. Your interaction factors are more than 1. If the spacing is less than this, you have to consider the P multiplier. With this, you can bring down your stiffness as well as your load carrying capacity of your pile group. That is how we will handle the group efficiency as well as capacity. Okay, this is what is your bending moment variation with respect to length or depth of the file. In case of single file, it is a tremendous, but the maximum moment in all the row of piles is exactly at the same level, subject to earthquake loading. See here, row 1, 2, 3, 4, 5 with respect to that particular file configuration. This slide I have taken from Rollins and others paper. See, basically single file has greatest bending moment. Leading row, this is a leading row. That means row 1 has the largest n in the group. Usually these trailing rows will going to have, maybe after third or fourth or fifth row, they're going to stabilize. Invariably, they're going to carry the same load and same bending moment. Okay, if embedded pile cap, you have to respect this pile resistance. Only thing you have to compact properly, then only you have to consider. That's the reason I told earlier, note excavation outside the forms. Okay. Anyway, I'll rush through that. You please just go through these things, you'll understand. Then how are you going to get the stiffness coefficients for the dynamic analysis? This is very, very important. See this particular formula. Anyway, theory is given over here. Especially your elastic resistance is in phase. Your viscous is out of phase by 90 degree. Let's assume I know how to get the K static. Already I have given the explanation. Then you have to have the multiplier. It's called a stiffness multiplier, but it is a function of frequency. Because earthquake loading means you will going to have the n number of different frequencies. Depending on the frequencies, it's going to vary. Now you see carefully this particular slide. We have considered this variation, and this variation. Already these formulas are given. I have extracted from this table. This table is given in foundation vibration chapter written by Gadgetas. It is available online. Then how are you going to get even damping coefficients and all? See this carefully. And then what you have to do here, if you plot and then see carefully, this is what is our non-dimensional number, that is omega d by Vs, where omega is the frequency of your ground motion, d is the diameter, Vs is your shear wave velocity. See this carefully, what will happen to your KHM and then your KHM and all. No doubt they are non-linear. If you draw one line, Okay, idealization. See this carefully. What will happen? Frequency dependence for single piles not that strong. If it is subjected to lesser earthquake loading, take for example, you have moderate earthquake loading, 5.5 and down. That is a earthquake magnitude expressed in terms of Richter scale. If it is 5.5 and down, that means this effect is not that strong. That means you can consider your this particular K of omega, your K of omega as 1. Start with. Okay, once you consider, basically you can make this statement. Not uncommon to assume K of omega is equal to 1. Even though it is dependent on frequency, still you can consider your multiplying factor as 1, and then you can go ahead and then analyze. Basically, now I will do. How are you going to analyze? It's a direct analysis. Pile supported bridge pier and then your bridge deck. Model entire soil pile structure in single analysis. Then you can compute the response of your structure. This is what is idealization from the physics. You can extract. Then you can introduce the nodes. You are defined into different pile segments as well as your bridge pier segments. Now, basically, what you have to do, you have to apply all these springs in order to take care of lateral loading, in order to take care of vertical loading with the TZ and QZ. Once you have done this, basically what you have done earlier, you have already evaluated your ground response. That is what is your pre-field response. You please apply all your pre-field response at all these points. You are disregarding the soil using these springs. Then you have to apply all your pre-field motion. Basically, it is the acceleration. Then you have to compute the coupled response. That's what you are doing. In case of structure approach, you please cut at this level. It's called as a mud level. Let's assume it is in river. Then you see basically what are you doing? Cut piles at mud level and replace with springs and dashboards. See this carefully. Let's assume it is a 2D analysis. That's the reason you're going to have the 2 translation and 1 rotation. That is how I represented. Next, what you have to do, you apply kinematic pile motions, what you have evaluated earlier along all these springs, and then compute the response. That's all you have done. This is how we're going to make use of the substructure. Then one more step is there. Just see basically what you're doing. Cut the pile at pile cap level. That's what I have done over here. Then replace with springs and dashboards. That is how I have replaced with springs and dashboard. And then apply kinematic pile motions to all these springs. This is a horizontal spring, vertical spring, and rotational spring. And then compute the response. Okay, this is how we're going to compute the response. That's it. Now you see basically what happened. These are the interpretations from substructure modeling. Substructure modeling can provide exact solutions for linear system. Basically, if the soil is strong, your structure is perfectly all right. If it is subjected to moderate earthquake loading, you will going to get exact responses even if you use a finite element analysis. Can iterate approximation to non-linear behavior using equivalent linearization. Even though you suspect there are non-linear effects in soil as well as in foundation, you can use equivalent linearization approach in order to evaluate your structure response. There is no direct way in case of substructure modeling to handle the non-linear systems. And then these are the conclusions. Physical behavior of deep foundation is very complicated. By seeing the slides, I hope you can appreciate this statement. For buildings, kinematic interaction can affect foundation input motions that I have already shown. Inertial interaction effects are also important. For bridges and wharves, kinematic interaction effects can be very significant. Kinematic effects due to permanent deformations can be crucial, especially for the bridges. If the bridges are on the rock, especially your fault systems, then you're going to have the permanent deformation. You have to account for that. Inertial effects, anyway, they are very important in case of bridges and wharves. With respect to inertial interaction, estimation of stiffness becomes very, very important. Basically, you are going to add the stiffness of your soil foundation system to the structural system. Single piles resistance mostly flexural. For pile groups, resistance is provided by flexural as well as axial. I have already shown the spring coefficients for this. Pile cap stiffness can be significant if your backfill is compacted properly. Otherwise, one should not consider. Most often, you are using factor of safety as 3 on KP because of sometimes it is not possible to compact just outside your foundation. Actual, that means approximations to actual behavior frequently required. You have seen a lot of approximation. Without approximations, you cannot perform soil structure interaction. Only thing, further understanding is needed. Once you have a sufficient qualified understanding about the soil structure interaction, you can do refined analysis. However, it requires a communication between structural and geotechnical engineers in order to analyze properly soil structure interaction effects, whether the pile is there or whether the raft foundation is there. Accordingly, one has to go for soil structure interaction analysis. Thank you. These are the concluding remarks, especially for the youngs one. Please see very carefully. Structure seldom built earthquake proof, but built earthquake resistant. Geotechnical considerations play a vital role in evolving design ground motions and earthquake resistant design. Basically, it is our activity to give the design ground motion to the structural engineer. In turn, they will use those in order to design structure for earthquake resistance. Seismic codes help in designing earthquake resistant structures. We have seismic code. You can use that also. Sound construction practices are extremely important. One should not think of some other attitude during construction. That's the reason there is no margin. That means never compromise on quality of construction. No matter how complicated analysis tools you have, no matter how complicated design tools you have, if you are not constructing, you will never going to do anything great on the ground. It is indeed possible to incorporate earthquake resistance measures economically. Don't think if you consider earthquake loading, you will not going to design your structure economically. It's not like that. Hardly maybe 10 to 50% of your total estimated cost will be the earthquake resistant design cost. Above all, awareness. That means earthquakes do occur. That much knowledge is must. Once you have that knowledge is not enough. You have to have proper understanding. Once you have proper understanding, on top of it, you have to have will to implement or will to do whatever you have understood so far. Are the mantras for successful utilization of any tool for the soil structure interaction analysis. Thank you. That's it. Hello.
Thank you, sir. Thank you, sir.
Madam, any problem happened in between?
No, sir. No, sir.
Maybe I have covered a little fast because of number of slides. Please anyway send to all the attendees.
Yes, sir.
In case they have any questions, I am ready to answer, please.
Yes, sir. There are a few questions, sir. Shall
Yes,
we
sir.
start with the question and answer session, sir?
Yes, please. Yes, please.
Yes, sir. Sir, first question is, usually superstructure and foundation will be analyzed and designed separately, like superstructure in ETAPS and foundation in SAFE. But if we analyze these together, it will make the analysis more complex and time consuming.
Yeah, because see, that is how we have learned, no? The practice followed so far is only that one. That is perfectly all right. When you are considering only linear behavior, you don't have to worry. That is what I told, no? When you are considering linear behavior, there is no point in considering single goal. Basically, what will happen? No, it is going to take a lot of time. When you analyze together, you have a soil, you have a foundation, you have a superstructure. When you consider all three together, that means soil, foundation, structure, interaction together, you have to spend a lot of time, then you have to spend a lot of resources. If you are restricting all your complicated analysis to linear analysis, better one has to separate and then analyze. You're not going to have any complications. No, it is not correct. You don't have any complication. Maybe it may take some time. That's it only. Otherwise, your results are reliable. Even your foundation design is also reliable. Even structural design is also reliable. If you respect non-linearity in soil, if you respect non-linearity in your structure, then you have to go for non-linear penetration analysis, considering the soil structure interaction effects. Many a times people are not fully aware how to account the interaction effects in the analysis. That is the reason they are neglecting. If your structures, high-rise structures, let's assume you have 200-meter tall structures are very close. The distance between them is hardly 10 meters. Because of the soil structure interaction effects, there is always a ponding chances. Okay, you understood?
Yes, sir.
Okay.
So next question is, when we model the foundation along with the superstructure, can we able to understand the effect of unequal settlement of the foundation on superstructure?
Everything, please, everything. Finite element will going to give all responses at all the nodes. Let's assume if you suspect, depending on your subsoil profile, you will be knowing the soil profile. Your structure is very large. Let's assume it is 100 meter by 100 meter. Definitely, you are not going to have the uniform subsurface profile below your foundation, right? Definitely, depending on your borehole, you'll going to suspect, yes, this part of my building may settle more. Definitely, you're going to have the differential settlement. That you're going to get it. That's the reason you have to go for a file foundation and rough foundation. Somehow you're going to compensate your non-uniform settlement. Finite element will going to give everything. Finite element is so powerful, especially your Abacus software is very powerful. Most of the constitutive models are there with respect to soil as well as structure. Even you can model non-linear dynamic analysis also. Everything is possible, please. I have already given few slides, no? Pile supported structure beginning as part of the big picture. That's paper is available online, please. They have used Abacus. They have given all the results.
Okay, sir. Next question is from Prithvik. Dear sir, usually we have basements in the buildings. Kindly let us know consideration of retaining wall in the mathematical model. We have observed all the lateral forces are concentrated to retaining wall? Is it okay to neglect modeling the
No, no,
retaining
no,
wall?
no. No, no. If you have a basement, maybe 1 or 2 or 3 stories for parking, you have to design that retaining wall as a shear wall. Only thing your retaining wall is supported by the slab up and down and then the column laterally. That is very simple, please. Now you have to understand a little bit about how people are analyzing shear walls. That you have to consider the lateral loading coming from the soil itself as well as earthquake loading. It is a must. Otherwise, what will happen? It will be punctured. Your retaining wall is not a just retaining wall. It is a shear wall supported on top and bottom by slab, side by your columns. Possible. You should not neglect, please. If it is not in seismically active area, then you can analyze and then you can neglect, nothing wrong in it.
Okay, sir. Thank you. How soil liquefaction affect on deep foundation?
Yes, yes, I already showed. No, one pile I have taken in the uniform soil as well in layered soil. If the soil is going to liquefy, your initial stress strain curve will going to become soften. Basically, what will happen? Your stiffness will come down, deformations will increase. If your pile is not designed properly, that means it is a pile in air. Initially, you thought pile in soil so that soil could able to offer resistance in the form of skin and end bearing. Now your skin resistance will be not there, even end resistance will be not there. Okay, considering this, you have designed your file accordingly. You have put your rebars. Now your rebars are less. Your dimension of your pile is very less. It will be cut off because of the maximum bending moment. Yeah, you have to consider piles in liquefable soils. There are many books. Yes, they will going to reduce the stiffness. Then the failure is imminent. There are many ways. Basically, what you have to do, you have to analyze for. Then you have to increase the number of piles, or else you have to improve the ground. Then construct the file foundation. Then construct your superstructure. Possible, please.
So next question, in coastal belt, what is the effect of water table in deep foundation construction?
Definitely similar effect will be there. In the coastal, basically, you have to consider, you have to account for it. If that coastal area is a non-seismic area, you don't have to worry. You consider the effect of basically pore pressure in order to evaluate your skin resistance and end bearing. If at all any fluctuation is going to happen, you consider that. No problem. If that area is subjected to earthquake loading, you have to be very, very careful. Okay, during earthquake loading, at what is the exact location of your groundwater table or whatever your sea interaction, then you have to provide for. There are many constitutive models are there how to account for the variation in the behavior of your clay. Basically, coastal means clays will be there. You can model accordingly. But your rate of loading is too much. Yes, soil may respond differently compared to the slow cyclic loading. Especially for your wave loading, you don't have to worry much. Wave loading is a slow cyclic loading. Usually it will take more than 5 seconds, 10 seconds to come have another cycle of loading.
Okay, sir. Above how many floors we have to design foundation for building? Because nowadays,
How many?
for
No,
residential, above how many floors we have to design foundation for building? Because nowadays, residential building foundation, they build us own by a mason.
no, but see, when you talk about if the ground is very good, if it is perfectly all right, then geotechnical engineers not needed. You please understand this. Let's assume you have a rock, good rock, no joints, no water table in the vicinity of your foundation. Then mason is quite okay. There comes the experience. No, experience is ultimate. Most of the time, experience comes by foolishness, not knowing properly. But if you are allowing a mason to construct the high-rise building, that is what is happened in Mauliwakam. They have not understood the behavior of clay. Clay creep. It is because of creep. Okay, they could have waited. They could have taken number of years to build the structure. They could have avoided the failure. The creep is very, very important in case of clay. Okay, you cannot allow mason to build. You understand the soil properties. You have to drill a borehole. Without drilling a borehole, how can you get the subsurface information? Many times people are cooking and giving the subsurface profile. Based on that, you are going to evaluate the shape bearing capacity. Then you are analyzing accordingly. Whether a shallow foundation is okay for this building or a deep foundation is okay for, accordingly, you'll go ahead. No. Analysis is a must. Soil exploration and then derivation of the subsurface profile is a must. Without that, one should not do anything. Your mason may not be knowing what is borehole, what are the soil properties, what is shape bearing capacity now. Based on experience, yes, he can do it for 1 story or 2 story or 3 stories if the ground is perfectly all right. Next, please.
If piles are resting on rock with anchorage, do we need soil structure interaction?
See, the anchoring, it is not called anchoring, it is a sucketing. Okay. rock sacketed piles. You cannot anchor. That's called also anchoring in loose term, but it is called sacketing. Yeah, still it is needed. If you are considering the shaft resistance, then the soil structure interaction is needed. If you are transferring entire structural load at the tip, where you are sacketing your pile tip to the rock, then you don't have to consider. If the same setup is subjected to earthquake loading, yes, you have to consider the soil structure interaction effect. If earthquake loadings are not predominant, then no point in considering soil structure interaction effect.
Okay, sir. There is one more question. Whether ANSYS software is suitable for doing soil structure interaction of tall structures?
Yes, please. Yes, please. Tall means how tall?
Uh, that is not specified in the
How is
picture.
relative? You are talking about 100 meter, 200 meter, 300 meter?
Okay.
See, all softwares are very powerful, madam. Only thing, they may not have a required constitutive model. Now, all software you can add on. You can write your own program, execute it and join. You can bring in your constitutive model. You can bring in your analysis procedure. Anything is possible. I'm not propagating Abacus or ANSYS. Anything you can use. All softwares. Right now, problem with all software is the damping. Actually, damping is not represented properly. For that, one has to do little more research. Then you can bring in the damping information, more reliable one. Then you can perform the soil structure interaction. Any software can be used.
Sir, one general question is asked by Raju K. What are your views on impact of COVID-19 on future R&D activities in civil engineering?
Not only in civil engineering, madam, right now they are pumping money in biotechnology and medical field. Anyway, private people are not funding. If that is private funding is ruled out in India, it may take another 50 or 100 years. The private people, unless if they are getting something, there is a profit, then only these pharmacy companies will invest. Otherwise, nobody will go into it. Right now, what happened? Lot of money is diverted or siphoned towards that. Maybe in 2-3 years, we will going to get less funding, but nothing will be there. These are all temporary. No, anything has come in between. It has to go in between. Maybe few more months afterwards, this COVID will go. Okay, that some impact will be there. If the particular person is powerful, theoretically is very sound, use a computer, sit in your own house, you can do it. That is what we are doing in IIT. We have all the softwares, we have computing ability, programming ability, and will to do. Knowledge is there, understanding is there, will to do is there, good friends are there, good coordination is there, good team is there. Yes, you can do it. Why you have to depend on 21st century? One should not depend on government for these things. You have to depend only on government for security and safety. If that is your intention, you can do anything. Sitting even in one bathroom. Forget about going to America or elsewhere. Okay?
Sir,
Yes, sir. Yes, sir. Thank you, sir.
sir, why is the time period more in continuum method than in modified Winkler method?
Everywhere it is more, please. I have not told like that. Effect of soil structure interaction is independent of both. Both are analysis procedure. Over the years, what happened? People were not knowing how to bring in the continuity of soil. That is the reason Winkler hypothesis has come in. They have replaced the soil with independent bed of springs. That is what I have shown. Nowadays, there are techniques to bring in the continuity even in the springs. Coupled springs are there. That is what I have not shown. Those are the advanced analysis using Winkler hypothesis. Nowadays, softwares are so powerful, understanding is enough. Then you can go to the direct. Direct is very simple. Only thing you have to have a more computational, what you can say, ability. Your computational tools are supposed to be effective. Okay, then you can do it. There is no difference, please. Don't bring that in. Those are the analysis tools. Successfully, they have improved. You can disregard your Winkler now. If you don't like, you don't use. But for some analysis, one should not invest too much time and resources. If you use a finite element, it will going to take a lot of time. Even though Winkler hypothesis, I use a finite element for structure. Only soils I have replaced using equivalent springs in order to take care of vertical, lateral, and moment loading. Okay?
Yes, sir.
Okay. Any questions, please?
No, sir. We have, thank you, sir. We have come to the end of this webinar. Let me first of all start by giving glory to the Almighty God for making today's occasion a memorable one. I thank our resource person, Dr. G.R. Doddagoudar, Professor, Department of Civil Engineering, IIT Madras, for accepting our invitation and for gracing today's webinar. Thank you, sir. It was a very wonderful and very informative session. You have given us a brief insight on soil structure, interaction, soil dynamics, sustainable development, and deep foundation. Thank you so much, sir.
Thank you, please.
I thank our management, principal, and HOD for their unstinted support and guidance. My heartfelt thanks to Ms. Pranamya K, convener, and to all our faculty members for making this webinar a resounding success. Finally, the wonderful participants who have turned up in great numbers. Thank you so much for your active participation and kind cooperation. The feedback link is shared in the chat box. Kindly fill the feedback link and you will be receiving the e-certificate within 2 or 3 days, 3 working days. Thank you so much. Thank you one and all. Have a great day. Stay home and stay safe. Thank you all.
Few more questions were coming. Those questions will be posted to the speaker and the answers will be sent to your mail ID. Thank you.
Thank you.
Good.
Yeah. Save event files ಅಂತಿದೆ.